Hello everybody, today we'll be doing two things. I'll be showing you guys how to take a cross product, and we'll also be finding vector orthogonal to two given vectors. So, let's take a look at this question. It's asking us to find two unit vectors orthogonal, which just means perpendicular, to these two given vectors here. Okay, so first thing I'm going to do is give you the order of operations actually. What we will be doing to solve this problem, and then I'll get into obviously solving it, but firstly, after this, I'll get into how to take a cross product. What you're going to want to do is you want to take the cross product of vector u and vector v. After that, you want to find its unit vector. Okay. Then you multiply that. No, that's it. Yeah, you just find its unit vector. Okay. It's quite simple, and it says two unit vectors. I'll show you what that means. I like to call it just the plus or minus, because it's same perpendicular vector in magnitude, just going in two different directions. It's quite simple. Let me show you how this is done. So we have ijk, our three dimensions that we're working with here. We just plant in our corresponding dimensions from each vector. If we look at vector u, 3, 3, 4, or -4, ijk, because they're corresponding, obviously. And the same for vector v, 0, 2, 3. Corresponding, okay. 0 in the I, 2 in the j, 3 in the k. Then we have this formula here. Now this looks a little complicated. If it does, it's fine. I'll show you how to do it. It's actually much easier if I just go here. We'll just say I, j, k. Okay. Because these are just three components to the cross product vector. Okay, you know what? Just follow my lead, boys. This is how it's done. Don't worry, I got you. You want to find the I of this vector. First row goes away. First column goes away. You have a 2 by 2 matrix. 3, -4, 2, 3. Okay, that's for the I. Now from the j, you subtract the j from the I in this formula. First row again, this time second column. Okay, 3, -4 are pairs, 0, 3 are pairs. Boom. Next we add the k. First row gone, third column gone. 3 and 3 are pairs, 0 and 2 are pairs. We can see that here, 3, 3, 0, 2. Okay. Now, to get this bad boy, what we have to do, and I just arbitrarily named the resultant vector as vector A, just for ease, but to actually solve for the I, the j, and the k, what we do is we take the cross product, and what that means is literally crisscross, boom, cross multiplying. The 3 multiplied by the 3, which is 9. And then in the equation, you're actually going to also multiply these two, -8, but you'll be subtracting this. We'll just call this like d. We'll call this b. b minus d. The product of d, well, this product, which is d, we'll be subtracting that from b. So 9 minus -8, 17. Okay, minus, don't forget this. 3 times 3 is 9. -4 times 0 is 0. So 9 minus 0 times -1 is -9. Then here, 3 times 2 is 6. 3 times 0 is 0. 6 minus 0 is 6. Cool. Awesome. So that's how you take a cross product. I guess there's more. It's not that bad though. We just get the unit vector now. All we do. We take the absolute value or the magnitude, boom, boom. As you can see, you guys have definitely done this before. 17 squared, 9 squared, 6 squared. Take the square root of that. Multiply that with vector A. So actually, let me figure out something. Let me just do this instead. This is much easier. It's actually less steps. And I'll show you what it means by two vectors. Oh my god, what did I just do? And hold on, I'll explain what I'm doing in a second for the second vector. Okay, I just had to get this in. So what I did was, if you were unable to follow, this looks maybe really complicated to you, don't worry. We're just finding the unit vector of vector A we found by taking the cross product. Okay, so that's 17 divided by the magnitude of A, negative 9 divided by the magnitude of A, 6 divided by the magnitude of A, all in vector form. And it asks for, I might have said this already, but I'm going to be honest, I shot this twice because I fat fingered a negative sign the first time and it got it wrong. So I had to restart, and my handwriting was really bad the first time. But anyways, I might have said this, I might have not, I'll say it again because it's very important. Two unit vectors, well, they're unit vectors. Basically, what you're, well, okay, so no, they want it to be two orthogonal unit vectors. Orthogonal means perpendicular. It's perpendicular to both of these guys. Well, one unit vector is perpendicular in this way. Okay, right? This is just one arbitrary unit vector. Let's just say it was the first one we found. And then all I did with the second one was I made it negative. So it's still perpendicular, has the same magnitude, it's just going in the opposite direction in that plane. But since but it's still perpendicular to the other two vectors. As you can see, this is an example.